Good afternoon, good evening, good night, good morning, depending on when you're watching this video. Okay, in this video, we're going to be working through the exercises starting on slide 35 of lecture set number 3. So these exercises are going to focus on combinations. So we are going to be utilizing the combination rule from slide 34 in each of these problems. Okay, the first problem in Lotto 649, 6 numbers are drawn from a drum with 49 possible numbers. So there's 49 numbers that we are picking 6 numbers from. How many different winning lines are possible given that the order doesn't actually matter? So this is how Lotto 649 is actually played. So you can win if your line has the 6 numbers in them, regardless of the order that they appear. So in this case, since order doesn't matter, we have a combination. So we are going to use little m is equal to 49, little r is equal to 6. Okay, so that means that we are going to have 49c6 is equal to 49 factorial over 6 factorial, 49 minus 6 factorial. So this is 49 factorial over 6 factorial times 43 factorial, right? So we can do a little bit of reduction here. It doesn't matter all that much, again, because most of our calculators will be able to handle this. But this is going to reduce to 49 times 48 times 47 times 46 times 45 times 44. Okay, divided by 6 times 5 times 4 times 3 times 2 times 1. And in the end, the thing that we're really looking for is just the number of outcomes. So that means that there are 13,983,816 possible combinations of lines if we pick 49, or if we pick 6 numbers from 49. So there's, every time you play the lotto, every time they reset it, there's 13,983,816 possible lines available. All right, what is the probability you win if you buy one line of numbers? All right, well, the probability of winning on one line is a fundamental probability problem. So we have little f over n. If we buy one line, there is the number of ways we can win is 1. There's only one possibility for winning, right? And then that's going to be divided by all of the possible outcomes, which we calculated in part A. Okay. So this is going to give us a very low probability of winning, something times 10 to the 9, I imagine. Oh, times 10 to the 8. Okay, so this is 0.1, 2, 3, 4, 5, 6, 7, 7, 1, 5. 8, right? So this is a 0.1, 2, 3, 4, 5, 7, 1, 5%. Okay, so that means rather 0.00000000715% chance of on one. Wow. Okay. All right. In the second problem, we have the US Senate consists of 100 senators, 2 from each state. A committee consisting of 5 senators is to be formed. How many different committees are possible? All right. So in the first problem, we want to figure out how many different committees of size 5 can be formed from 100 total senators. Okay, so this is a fairly easy problem. So we have 100 total senators. We want to build a committee of size 5. Order doesn't matter in this case because we're talking about people. So if I pick Senator 1, or like the first senator from Hawaii, or sorry, not from Hawaii. If I pick a senator from Florida, and then I pick a senator from, actually, I think Hawaii would work, but let's say, just for clarity, I pick a senator from Florida and a senator from Texas. It doesn't matter if the Texas senator enters first or the Florida senator enters first. Okay. So this is a combination. So we have 100C5. So this is 100 factorial over 5 factorial, 100 minus 5 factorial. So that's going to be 100 times 99 times 98 times 97 times 96 divided by 5 times 4 times 3 times 2 times 1. Okay, so 100C5, and that gives me 75,287,520 different possible committees of size 5 from 100 different senators. All right, how many committees of size 5 can I form if no state can have more than one senator represented? Okay, so in this problem, what we are trying to do is determine all of the different committees of size 5 that can be formed if every state has to be represented by only one senator. So you can have a senator, you can't have two senators from the same state. Okay. So first off, the first part of this problem is basically asking how many different committees of size 5 can be formed if I have 50 states available to me, right? So I want to draw one senator from each state. So the first part of this calculation is going to be 50C5, right? And then this is one senator from each state, okay? Now, what I have to do next is I have to consider that when I draw, or let's just for clarity, let's say that this is selecting 5 of 50 states. Okay, that'll make this a little easier to explain. So I've selected 5 states. So 50C5 counts all the different ways that I can choose 5 states from the 50 that are available. When I select a state, I have 2 choices for the senator that enters onto the committee. So I have 50C5 times 2C1. So I'm choosing one senator from the 2 possible within each state. Okay, so this is choose one senator from 2 available in each state. Now I have to repeat this calculation for all 5 states. So the first 2C1 is for state 1, okay, in state 1. Okay. Now the second 2C1 is choosing one senator from 2 available in state 2, right? So this is state 2. And then there's 3 other states I have to consider. So that's state 3, state 4, state 5. Okay. Okay, so this thing is 50C5 times 2C1 to the power of 5. Now, to choose 1, anything choose 1 is that number. So this becomes 50C5 times 2 to the power of 5. Okay, so 50C5 is going to be 50 times 49 times 48 times 47 times 46 divided by 5 factorial times 2 to the power of 5. Okay. And then that's going to be 67,800,320. Okay, so I just need to move this over a bit. 6, 7, 800, 320. Okay. So how many different committees are possible if each state can only contribute one senator? 67,800,320. Okay, part C. If the committee is selected at random from all 100 senators, what is the probability that no state will have both of its senators on the committee? So in this problem, what we're asking is probability each state has only one senator selected. Okay, so in part C, basically what we're asking is, what is the probability of observing the event in part B? So this is going to be 67800,320 divided by 75,287,520. Okay, and that's going to be 0.901. Okay, so 90%, 90.1% chance each state has only one senator selected. All right. So as always, if you have any other questions, please let me know.